Hello class, coming to you today with Module 4. We're going to be looking at that first section in Module 4, 4.1. Okay, so we're going to start with sharing my screen and dive right in. Okay, so Module 4 deals with normal distribution. This has to be the most important distribution. And we get a really good introduction, a really good breakdown of this module. If you have to take another statistics class again, you will most definitely see normal distribution. Every distribution eventually, when your sample space is big enough, eventually approaches normal approximation or normal distribution. Okay, but that's another story for now. We're going to leave that to the side, and we're going to just get started here looking at normal distribution. Now, first off, let me say this: every normal distribution would have a set number of a set value for the mean and a set number of standard deviations. When you think about all of the different possibilities you could have for mean mu, your mean value, your average value, and your standard deviation value, it's infinitely many bell-shaped curves you could form. Okay, the shape of a normal distribution is the bell-shaped curve. So what we have to kind of alleviate all of that work or all of those calculations that would take place with each individual distribution, we are able to standardize any normal distribution. When you standardize a normal distribution, you're taking that distribution's original given mean mu and deviation and making it normal with a set value of 0 for the mean and a value of 1 for the deviation. Okay, so the mean mu and then sigma is your standard deviation. All right. Now, in order to use the table, which is how you were taught in the lecture videos for this section, in order to use the table, you would have to transform that distribution that you're given to a standard normal if it isn't already standard normal. Okay. The way that you'll be able to tell if it's standard normal is you will be given z-scores. Okay. You will be given z-score, or you won't often be given a mean and a deviation. And so because you see z, you'll assume automatically that the mean and deviation have to be 0 and 1 respectively. And that is the case for this particular problem. They happen to actually tell us that it's standard, but notice that we see z-score, and they do also tell us that the mean is 0 and the deviation of 1. So it says find the area of the shaded region. The graph depicts the standard normal distribution with a mean of 0 and a deviation of 1. So the mean, the average is 0 and the deviation is 1. Okay? So when we look at a normal curve, majority of your data will lie very close, or at least within 2 deviations from the mean. And as you can see, as it tails off, fewer and fewer data is in the tails, and that means they're getting farther from the mean. The mean is at the very center of the peak. So majority of your data values will lie within about 2 standard deviations. Okay? All right. Let's get into this. Finding the area under the curve for this shaded region. So this shaded region is the area to the left of 0.82. The shaded region is the area to the left of 0.82. And that just happens to be perfect because when you're dealing with the table, your table is set up, and my printer didn't print this table great, but your table is set up or built to find areas that lie to the left. Okay? How do you find it? Let's look. I'm going to use the table, then I'm going to show you on the calculator. So we find the z-score 0.82, and then we find the corresponding area that goes along with it. Now, 0.82 is positive. So when you're looking at the standard normal table, you've got negative values and you got a negative side of values, or a negative side where your z-score is negative. Probability is always positive, okay? But you got negative z-scores one side and positive z-scores on the other side, okay? So we're looking for a z-score of 0.82, and we're looking for the area that's to the left. So when we find this z-score, that area in the table will be our answer because it will represent the area to the left. Take a look. This is shaded to the left, shaded to the left. So whatever area we find in the table, that represents our area to the left. So we're looking for 0.82. Now, your z-score, you've got numbers here. The first decimal place, or the whole number in first decimal place, are under z in a column. And then your second decimal place is out to the right here of z in a row. Where the two meet is your area. So we're looking for 0.8 here, and then we find the 0.2 here to form 0.82. So 0.8 is what I'm looking for right here. And then I find the 0.02 here. And then when I meet the two together, I get my area of 0.7939. It's hard to read, but that is 0.7939. Okay. Now, putting the table away, let me show you how you could use the calculator. Just like before we had binom PDF, binom CDF, we had shortcut keys for the binomial distribution. We have a shortcut key for the normal distribution, for any normal distribution. And it's called normal CDF. Okay, now let me explain to you. Because we're dealing with a cumulative area under the curve, you will always use normal CDF. You will never use normal PDF. Never, ever, ever. Okay, we're always going to be talking about an area under the curve, and this is a continuous function. So we're talking about cumulative area under the curve. Okay. In order to use this, you have to tell the calculator what your bounds are. You have to explain to the calculator where this region is located that you're trying to calculate the area of. So you got to tell the calculator what the left bound is, which is the lower bound. So lower bound, which is the left side. You got to tell the calculator what the upper bound is, which is the right side. Then you tell the calculator what your mean is and what your deviation is. Okay, so I have to tell the calculator by putting in these bounds and my mean and deviation where this region is shaded at, where the stopping point is on the left and on the right. Now, when you're dealing with normal distribution, remember I said this is a continuous function. What that means is it never ends. So even though it's starting to flatten out in the tails towards the left, it never ends. It approaches negative infinity. And towards the right, it never ends. It approaches positive infinity. Now, we don't know what infinity and negative infinity are. They're just some numbers that we never reach, okay? So we have to use a value to represent them. So for this particular region, it's shaded to the left. So from 0.82 to all the way to the left tail is where we're headed. So this left tail end is your lowest bound. That negative infinity is your lowest bound. What we're going to do is use negative 99999, maybe about 5 or 6 nines, to represent negative infinity. So we use negative, or you can use negative 1111. It's up to you. I like nines. Use negative 999 to represent negative infinity. And then, of course, if we had to, we would use positive 999 to represent positive infinity. Now, of course, we're not shaded to the right tail. We're not approaching positive infinity, so we don't need that. So our lower bound, our left side bound is negative infinity, negative 99999. Our right side bound, where it stops on the right, is the z-score, that 0.82. Because remember it says, or the graph is depicting the area to the left of 0.82. So our upper bound is the 0.82. So this is the lower bound, this is the upper. And remember, we're dealing with z-scores, we're dealing with the standard normal. So the mean is 0, the deviation is 1. And that is how we'll enter it into our calculator. So let's show that on the calculator. So you're going to press second vars, and normal CDF is number 2. You will never use normal PDF. Never, ever, ever use number 1. Okay? We're using number 2 because this is always a cumulative area or cumulative distribution under the curve. So number 2, normal CDF. Now my calculator has negative 1e99. That also represents negative infinity, but a lot of times students don't know where to get that little e from. So just type negative. Here's your negative key right here. Make sure you use the negative and not subtraction. Okay, so just type negative and just do a bunch of 9s. That's your lower bound. Your upper bound is the 0.82, so 0.82. Your mean is 0, your deviation is 1, so 0, 1. And then we're going to hit paste. And lo and behold, it's exactly, or the calculator looks like exactly like what I wrote down. Now I've got a few more 9s, but I didn't have to have that many. I just kept typing it because it was there, okay? But this represents negative infinity, okay? Your lower bound, this is your upper bound, then your mean and your deviation. And now we're going to press enter. And we get, rounding this to, let's see, 4 decimals, we get 0.7939. 0.7939. That 8 becomes a 9. All right. All right, that was number 2. Let's look at number 3. And sometimes these tables will automatically populate for these problems. Sometimes it will, sometimes it won't. For number 2 and number 3, it actually popped up. I'm going to use the calculator though. If you like the table, that's fine, but I personally prefer the calculator, especially when I get to areas that are not to the left. Areas to the left, remember your table is built or set up for areas to the left. This is an area to the right. So here's the thing. If I was using the table on this one, then the area that corresponds to 0.88 in the table is actually representing the area to the left. So if I take the table and I find the area, I would then have to subtract that from 1. Okay? Not terrible, and it would work just fine. You would just have to remember to subtract it from 1. Because if you give the table value exactly from the table for this number, it would be wrong. Because again, your table is built for areas to the left, and this picture is depicting an area to the right. Okay? I personally prefer normal CDF because eventually we'll get to problems that don't contain Z, and you can't use the table, or you'd have to do some translation in order to use the table. Okay? In other words, more work in order to use the table, when you can just get used to using the calculator from day 1. Okay? So I'm using normal CDF. I tell the calculator what my lower bound is, which is my left side bound. Okay, it's bounded, the shaded region stops or is bounded on the left side at 0.88, at my z-score basically, because we're looking for the area to the right of 0.88. So it is bounded to the right, I'm sorry, bounded on the left by 0.88. So that's my lower bound. Now keep in mind, it's shaded to the right tail, so it's approaching positive infinity. So my upper bound would be positive infinity, which I'm going to use 99999 to represent that. Okay. And then we're talking about z-scores. So standard normal. So my mean is 0. My deviation is 1. These values, let me make sure I'm clear, making this clear. These values are always the case, or always true when you're dealing with the standard normal curve, okay? When you're not dealing with the standard, but just some random normal curve, you will be given a specific mean and a specific standard deviation. On this problem, I was not given a mean and deviation because I knew it was standard normal because I was relating it to a z-score. And also, the question stated standard normal. So my mean is 0, my deviation is 1. And again, I'm going to use normal CDF, second VARS, normal CDF number 2. I've got 0.88 for my lower, 99999 for my upper, 0 and 1 for my mean and deviation. And then I hit paste. And it puts it on my home screen in the order in which you see it here written on paper. And I press enter. So the area of this shaded region is 0.1894. Okay? All right, number 4, and then I'm going to show you some different problems that don't necessarily deal with standard normal. Number 4, here, this was shaded here in the middle between these two. It just didn't print well. So we're looking for the area between negative 2.22 and 0. So I'm looking for a region that is bounded on both sides, okay? So it's bounded on the left side at negative 2.22. That makes this my lower bound. And it's bounded on the right side at 0, which is the mean technically because we're dealing with standard normal. It's bounded on the right side at 0, which makes that my upper bound. So when I use normal CDF here, I don't have to use infinity at all. I won't use negative infinity or positive infinity because it's bounded on both sides by real numbers. So it's bounded on the left by negative 2.22. That's my lower. It's bounded on the right by 0. That's my upper. And then my mean is 0. My deviation is 1. So normal CDF, negative 2.22, 0, and then 0 for my mean and 1 for my deviation. So I'm pressing second VARS, normal CDF. I've got negative 2.22. My upper is 0. My mean is 0. My deviation is 1. And there it is on my home screen. And I'm going to press enter. And I get 0.4868 because the 7 is going to go up to an 8. 0.4868. Okay? Hopefully this is making really good sense for you. Number 6 is in words. I just wanted to do this one. It's similar to what we just looked at. I wanted to do this one because I want you to understand that you're going to need to draw a picture sometimes. Notice that there's no picture here, okay? But if you'll draw your picture, it will make finding the bounds, the lower and upper bounds, that much easier. So we're looking for the area for the standard normal curve. We're looking for the area to the left of negative 1.45. So I'm going to draw me a curve here. Standard normal. Put 0 there at the center. I'm going to just do that on my sketch. I always do. And I like to do that because then I can gauge where my z-score is at. My z-score is negative, so it needs to be to the left here, somewhere to the left. I'm going to put it about right here. Negative 1.45. And I want the area to the left of negative 1.45. So that means I'm shading to the left here in this left tail. That's what that means. And so because I'm shading to the left tail, I'm approaching negative infinity. So when I use normal CDF to find this area to the left of negative 1.45, my lower bound is negative infinity, which I use negative 999. My upper bound is the bound on the right side, negative 1.45. My mean is 0. My deviation is 1 because we are dealing with the standard normal. My mean is 0. My deviation is 1. Okay? All right, so normal CDF, second VARS, normal CDF. We've got negative 99999. Our upper bound is negative 1.45. Our mean is 0. Deviation is 1. We hit paste. And that is now imposed on our home screen. And you can arrow over. You don't see the full word normal CDF, but it's there. And then press enter. So the area to the left of negative 1.45 is 0.0735. Okay? If you were using the table, you would find negative 1.45 in the table and in the corresponding area. Okay? You could do that as well. But remember, you won't always have this easy problem where you're given a z-score and you can use the table. Because if it's not a z-score, then you can't use the table until you transform the x value to a z-score. So this particular probability would be, this answer would be 0.0735. Okay? And again, just wanted to make sure I showed you that because it's just words. Take a look at this one. Now you're not given the standard normal, and the next problem you won't be either. Now you are given just some normal distribution with a given mean and a given standard deviation. Okay? And we want to find the probability that x is less than 82. I don't have a picture. The first thing I do is draw a picture. Okay? And I always label my picture with the mean at the center. The mean is 90. Okay? Now, you're looking for the probability that x is less than 82. Well, here's 90. 82 is less than 90, so I'm going to put 82 to the left somewhere. Doesn't have to be perfect, just put it somewhere to the left. Okay, so here's 82. There's a line, the bound there, the line that's at 82. And we want the probability that x is less than that. Less than 82 means this area to the left is what I'm trying to find. This shaded area here to the left. Okay, so it is shaded to the left tail towards negative infinity. That's what I want to find. And I'm still going to use normal CDF. But here's the kicker. I'm going to use the original values that I'm given. We don't have standard normal, so I can't use 0 and 1. I have to use the mean and deviation that I'm given. Now, if you wanted to use the table, you would have to transform this. Okay, you would follow what the lecture video state. You'd have to transform this x probability statement to a z-score probability statement. Okay, and then you would be able to use the table. But I recommend, because in the next section that we look at, you're going to be dealing with problems that require a little bit more work. You don't want to have to translate them to z-score first and then use the table, and then, because it's some extra stuff, you want to get comfortable with the calculator, okay? So normal CDF, my lower bound is the negative infinity, so I've got negative 9999. My upper bound is the 82, so let me put lower, because lower is left. Remember, LL, lower left, okay? So the bound on the left side is the lower bound. The bound of where it stops on the right is the upper. And then you've got mean, and then you got deviation. Okay? So we're going to press second bars, normal CDF. My lower bound is negative 99999. My upper bound is 82. My mean is 90. My deviation is 5. And I hit paste. And there's my probability, 0.0548. That 7 is going to become an 8. So let's just say 0.0548. Okay? And again, I hope this is making sense for you guys. Look at the video again if you need to. All right. Let's look at this one. So here we're looking at 2 or 3 or 4 probabilities that we're trying to calculate. Kind of a word problem, kind of short, but we're basically doing what we did on number on number 8, it's just written in words, and we'll have to write it in a probability statement. So this is written out in words. We'll be setting it up like this, okay? So let's look at it. It says, in a survey of a group of men, the height in the 20 to 29 age group were normally distributed with a mean of 69.3. So I'm going to put mean 69.3 and a standard deviation of 2. So standard deviation is 2.0. Okay? Now, it says a study participant, which is your X, is randomly selected. Compute or complete parts A through D below. So part A says, find the probability that the study participant has a height that is less than 67. So we're looking for the probability that X is less than 67. Okay? That's what we're trying to find on part A. Probability that X is less than 67. How did I know we were dealing with X? Because I was given a mean and deviation other than 0 and 1. When you're given a mean and deviation of 0 and 1, that's when you're dealing with z-scores, okay? But this is an X random variable. All right, I'm going to go ahead and translate them all. Part B says find the probability that a study participant has a height that is between 67 and 71. So in other words, this one is bounded on both sides, where X is in the middle, between 67 and 71. Okay, so that's what we will be finding there on part B. And then part C says find the probability that a study participant has a height that is more than 71. So probability that X is greater than 71. So it is so important that you can translate these correctly. Less than, translated to that less than inequality symbol. More than, translated to that greater than inequality symbol. And this number, or letter part B, uses the word between, where X was between 67 and 71. Okay? So let's just start here with part A. I'm going to write it down below. Probability that X is less than 67. You remember, a picture is worth 1,000 words. So I'm going to draw a picture where my mean is at the center, 69.3. And I'm going to use this picture. I'm going to label this picture with this probability statement. The probability that X is less than 67. Well, 67 is a little smaller than 69. So I'm going to put it here to the left. And I want the probability that X is less than that. So that means I'm shading the area to the left. Okay? So we're looking for the probability that X is less than 67. We're looking for the area to the left. And that means it is approaching negative infinity. So this would be normal CDF. Your lower bound would be the negative infinity. Your upper bound would be the 67. It's bounded at the 67 on the right. So lower bound, upper. Your mean is 69.3. And then your standard deviation is 2. Okay? All right. And I'll go ahead and put that in. So I would use second bars, normal CDF. My lower bound is the negative infinity. I got that in. So I would press negative 99999. My upper bound is the 67. My mean is 69.3. And my deviation is 2. And then I would hit paste. And there it is. I have a mean of 0.1251. I'm sorry, I have a probability of 0.1251, rounding that to 4 decimals. Okay. Part B would be similar, only it's bounded on both sides. X is in between 2 values. So I want you to see the picture as well here. And then I'll whip it in the calculator again. 67 is smaller than the mean, so I'm going to put it to the left. 71 is slightly bigger, so I'm going to put it to the right. And we're looking for the area between them. So that would also be normal CDF. My lower bound is 67. My upper bound is 71. My mean is 69.3. My deviation is 2. Putting that in the calculator, second bars, normal CDF, 67, 71, and then 69 and 2 remain the same there. The 69.3 is the mean. Standard deviation is the 2. There it is on my home screen. And I have 0.6773. That 2 goes up to a 3. Okay. Part C, one more here. Probability that X is greater than 71. Okay. Probability that X is greater than 71. So I'll show you a quick picture here. Your mean there at the center, 71 is bigger than the mean, so I'm going to put it here. And greater than 71 means we're shading to the right this time. So greater than, shaded to the right. Less than, shade to the left. Okay, so if it helps, think about less than left, LL. Okay, shade to the left. Greater than, shade to the right. Okay, so I'm going to use normal CDF again here. I've got my lower bound of 71 because that's what's binding that area on the left. It's approaching positive infinity to the right. So I would have 99999, not negative 999, just positive 99999. And then I'd have 69.3 and 2.0 for my mean and deviation. Okay, so second VARS, normal CDF, 71, 99999, 69.3, and 2. And it gets pasted on my home screen there, and I press enter. 0.1977. That 6 goes up to a 7 because another 6 follows it. So 0.1977. Okay. And that's all I had for that part of 4.1. You were looking at finding probabilities in the beginning part of 4.1, and then you get introduced to where you're given the probabilities and you have to calculate you're given the areas. Yeah, you're given the probabilities. I said it correctly. You're given the probabilities, and then you have to find the corresponding score that goes with it. Okay, so it's called inverse norm. It's the reverse of this topic. So I'm going to show you a few of those because I want to show you how to use the calculator on them. Okay, so look at number 10 here. It says use standard normal table to find the z-score that corresponds to the cumulative area. So think about it. You're given the area and you're asked to find the z-score. Now you can use the table, and if you're using the table, what you would have to do is you would go to the body of the table. You would go to the body of the table. You would find the area, or as close to it as possible, and then the z-score that corresponds to it would be your answer. So I'm going to show you that. Now our area that we're given is really small, 0.0052. So that means because it's so small, that means we're looking for a negative z-score. If it's less than 0.5, if your area is less than 0.5, then it's a z-score that's going to correspond to it. If it's greater than 0.5, then it's going to be a positive z-score. Okay, if it's less than 0.5, it's going to be a negative z-score that'll correspond to it, which is what we have here. We're going to have a negative one. So I would go to the body of my table and I would find 0.0052. So let's look at it. I'm talking about numbers that have 2 zeros. Here we go into the 2 zeros. And there it is right there, 0.0052. I'm going to circle that area. And the z-score that corresponds to that is negative 2.56. Here you get the whole number and first decimal place. And together, combining it with the number above it, you get the second decimal. So that's negative 2.56. Okay. I want to show you how you can also use the calculator. If you're using the calculator, then you're going to use something called inverse norm. You're going to tell the calculator what the area is to the left. and then what the mean is and the deviation. Okay? You always have to use the area to the left. And I say that because even though the new calculators like mine will let you use the area to the right, the area in the middle, it will, the 83 calculator will not. So you want to get used to just always using the area to the left in case you ever have to use a calculator that won't let you change it, if that makes sense, okay? So inverse norm, you're going to find that under second vars. Remember that the distributions are all under vars, under the second function of the vars key. So inverse norm is that third key right there. So I'm going to tell my calculator what the area is, and cumulative area is representing the area to the left, okay? That means the area to the left, the area behind you, okay? The accumulation up to that particular z-score. So our area to the left, or our cumulative area, is 0.0052. And because we're looking for a z-score, that means we automatically have a mean of 0 and a deviation of 1. Remember, z-score is standard normal. So that is a mean of 0 and a deviation of 1. Okay? All right. And then I go right here. I do not change this, okay, because you don't always have that option on every calculator. So I'm just going to keep that on left or act like I don't even see it and go to paste. Okay? So on your calculator, you may not see that left. You probably just see the area, the mean, and the deviation value. And then you press enter. And look what we've got here. Negative 2.562223. The calculator, of course, is more accurate, okay, than the table is. The table has already been rounded off to 2 decimal places. So we would have to technically round that. Negative 2.56. Okay? Pretty straightforward. All right, and then that brings us to this problem that I want to make sure I show you how you set it up. You're also going to be using inverse norm here, and I recommend you use inverse norm. That way you don't have to worry about transferring or translating it from a z-score to an x. Use your calculator, okay? So it says the undergraduate grade point average of students taking an admissions test in a recent year can be approximated by a normal distribution as shown in the figure. So you're given the mean and you're given the deviation here, okay? Part A says, what is the minimum GPA, university GPA, or undergraduate GPA rather, that would still place a student in the top 5% of undergraduate GPAs? So let me look at part A. I've got this picture. I'm going to draw it again so that I can label it with my given information, okay? My mean there at the center is 3.26, okay? And I want to find what the minimum GPA will be that would place a student still in the top 5%. So understand top 5% is representing the area in the right tail. If it had said bottom, it would have been the area in the left tail. But this is area in the right tail, okay? And that 5% translates to 0.05. So the area in the right tail is 0.05. Okay, that's the area that we're given. Now, when I get ready to use inverse norm, though, I have to use the area in the left. Okay, area in the left tail, or the area to the left. So, very easy to do. I need you to think about it. These areas under these bell-shaped curves, the area under the normal curve, represent probabilities. And what have we been saying the sum of all probabilities is? 1. So if you've got 0.05 in this tail end, to get the area in this left tail or this other area here in this bigger portion, you would say 1 minus 0.05 because the total area under the bell-shaped curve is 1. So that means you've got 0.95 here to the left. So your area to the left would be 0.95, and you have a mean of 3.26 and a deviation of 0.18. And that is what we will put in our calculator to get the GPA, the minimum GPA, that would still place a student in the top 5%. So we use second vars, inverse norm. We've got 0.95, our area in the left tail, 3.26, and 0.18. And we hit paste. The minimum GPA needed, if we round that to 2 decimals, would be 3.56. Okay, 3.56. Now, part B, this last part here, it says we're looking for between what two values as the middle 50% of undergraduate GPAs lie. So here we're looking for two values. We're looking for the lower bound or the lower GPA on the lower end and the highest GPA. So I'm going to draw this picture as well so that I can label it with the middle 50%. So here we've got a lower bound and an upper bound that we're trying to find, and a middle 50% here. Okay? So I'm going to shade that so that it stands out. Okay? Remember, the total area under the curve is 1. So let's go ahead and change that to 0.5 here. It was 50%, so let's go ahead and change it to 0.5 or 0.50. Total area under curve is 1. Okay? So if you've got 0.5 here in the middle, then that means you've got 0.5 left to split between these two tail ends. So you've got 1 minus 0.5, which is still 0.5, that you got to split in these two left tails, or in this left tail and this right tail. So you would have half of 0.5 over here, which would be 0.25, and you'd have half over here, 0.25. So we're going to split in the two tails. Or split in between, I should have said, the two tails. Okay, now, I want the lower end GPA, then I'm going to use this area to the left of it. I'm looking for X1, which I'm calling the lower GPA. So to get that, and I'm going to put my equal sign up here with the X. I'm going to use inverse norm to get that. The area to the left of this X is just what's in this left tail that's to the left of it, 0.25. And I still have the same mean, which is 3.26, and the same standard deviation, 0.18. So that is my area to the left of this lower end GPA, and then my mean and my deviation. Okay, let's get that one. I'm gonna clear that off. I press second bars, inverse norm. I've got 0.25, 3.26, and 0.18. And then I hit paste, and it puts it on my home screen for me. So that lower GPA is 3.14. We're going to round that to 2 places, 3.14. Okay? Now, think about this one. To get X2, slide a piece of paper here, and I'm going to scoot it up some. To get X2, which is the upper GPA for this middle 50%, then I'm still going to use inverse norm, but I got to make sure I use the correct area. So here's X2. Okay, I'm looking for the higher end GPA. So what is that total area to the left of it? Well, it would be the 0.5 and the 0.25 all together. It's the total area that's to the left of it. Because see, here's X2 right here. The total area all the way to that left tail, the total area to the left of X2 is 0.75. The 0.5 and the 0.25 together. So I got 0.75 is my area to the left of it. And then I got my mean, 3.26 still, and my deviation, 0.18. Okay? And putting that in my calculator, second bars, inverse norm. I got 0.75 My mean and deviation did not change. I go down to paste, and it puts it on the home screen. Now, if you got an 83, you had to type that in your home screen as it is. You would put the area, comma, 3.26, comma, 0.18. And I don't know if I said this, the comma is right here underneath the sign key. Okay, whether you have an 83 or an 84 is in the same spot. All right, and I'm gonna press enter there, and I've got 3.38. So the GPAs that give you a middle 50% of all the GPAs would be 3.14 to 3.38. Okay, and I'm going to scoot it back down now. And again, that was the standard deviation there. And I would have it right here on these blanks, 3.14, 3.38. All right. That wraps up 4.1. Hopefully that cleared up any misconceptions that you may have had. Making sure that is clear for you. One more thing again, remember top represents the right tail. Okay, that's why I shaded to the right. If that had said bottom, it would have been the left tail. Okay, keep that in mind. Okay, and remember the total area under the curve is 1. I will see you guys soon.